Welcome back to this series on architectural simplification. Today we'll be looking at data warehousing, specifically around the unnecessary duplication or triplication of data. In today's before example, we'll see how data stored in a database and then published to an intermediary data source before being forwarded to a data warehouse can result in 3 copies of that data, which might not be necessary. The after scenario will reduce the total amount of data that we store by simply publishing data directly to the data warehouse from the database by way of an adapter. In today's setup, I'll be using a local copy of AWS called Local Stack and a BigQuery emulator. The actual infrastructure for the before example will look like this. I'll have CockroachDB, which will publish notifications by way of CDC. I'm using CockroachDB because it has CDC built in and it makes that a lot simpler for me. Events from CDC will be stored as objects in S3. That will be our intermediary data store for this example. I'll publish notifications onto SQS, which will trigger a Lambda event, which will be responsible for writing my data into the data warehouse. Let's go into what the infrastructure for the before scenario will look like. I've got CockroachDB. I'm running local stack, which emulates a local AWS environment. I enable S3, Lambda, CloudWatch logs, and IAM. And then I run a BigQuery emulator, which will serve as our data warehouse in this example. I'll create the AWS infrastructure using Terraform. I connect to my region, which is US East 1, arbitrary in this example because it's all local, and I specify a fake access key and secret access key, which I bypass anyway. Whenever Terraform tries to interact with S3, SQS, IAM, or Lambda, I redirect it to my local stack installation, and then I create the resources. I create an S3 bucket, an SQS queue, which will receive notifications from that bucket by way of a notification resource. I sort out permissioning for Lambda. This will be a Go Lambda, so I build the binary and archive it into a zip file before creating the Lambda using the zip file that I've just built. And I'll use the SQS notifications to trigger the Lambda. The Lambda itself is actually quite involved. Whenever I receive an event from SQS, I connect to BigQuery. I create a new session because I'll need that in order to be able to download the file that I received on S3. I create a runner to house the dependencies for this application, which are BigQuery and the S3 downloader. And then I send objects to BigQuery. For each of the records that I received, I unmarshal them into something my application can understand, and then I send the objects to BigQuery. First, I download the CDC message from S3 using the S3 downloader, and then for each of the messages that I receive from there, I insert them directly into BigQuery. Before we get going, I'll also look at the after scenario, which is actually a lot simpler. There's only 86 lines of code versus 215. In this code, I connect to BigQuery and I run the BigQuery adapter. The adapter is a simple post endpoint which will act as a webhook, which CockroachDB will directly connect to and publish CDC messages. For each of those CDC messages, I'll write them directly to BigQuery. Let's create the before infrastructure now. I've spun up CockroachDB, local stack, and BigQuery, and into BigQuery, I'll create an example dataset, and from there, an orders table. That's the dataset and table created. I'll now move on to local stack and run the Terraform infrastructure. I'll enable the enterprise functionality of CockroachDB because this will allow me to access some of the niceties around CDC. I'll connect to CockroachDB. I'll create the input orders table. I'll enable range feeds and I'll create the change feed. Whenever I see a new or updated order, I'll raise an event and that will result in a new object in S3. Let's keep an eye on BigQuery. I'll run a select against BigQuery every second so that we can see when the message arrives into BigQuery. And now I'll insert 2 rows into the orders table. Those orders have gone through S3, through SQS, and into our Lambda, which has written the orders into BigQuery. Now for the after scenario, I'll remove any unnecessary architecture, which in this case will be all of the AWS architecture. I'll delete everything from the S3 bucket, which will then allow me to delete everything in AWS. With that deleted, I'll connect to CockroachDB again and delete the original change feed that I created. CockroachDB's CDC webhook notifications require an HTTPS connection, so I'll now create a certificate that will allow me to do that. I'll run a server using the certificate I've just generated. I'll copy the base64 representation to my clipboard. I'll enable the new webhook sync, which provides better performance than the previous one. And then I'll create the change feed. This takes in the base64 representation of the certificate and publishes messages to my running adapter. Whenever I get any changes to the orders table, I'll publish a webhook notification. we can see that I've received 2 new messages. These are the new messages that have been picked up by the brand new change feed and published by way of webhook notification. I don't need those, so I'll delete them. I'll clear out everything in BigQuery, just so we've got a clean slate for when the new messages are published. And finally, I'll insert 2 brand new rows into the database. The new messages have been published by CockroachDB, picked up by the adapter, and written to BigQuery. The biggest win of the after scenario versus the before scenario is a vastly simplified application architecture with fewer moving parts. In the before scenario, any of the components could have failed for any reason. There were more network hops involved, meaning more could go wrong there. All of the components would have required separate maintenance. And for each of the third-party components, this time in the pipeline for AWS, we're at the behest of AWS's SLAs. If any of those components don't provide at least once or exactly once delivery semantics, all bets are off. In the after scenario, there were less moving parts and less data duplication, meaning fewer network hops, less network transfer, less storage, and hence lower cost. And as a side effect, we saw that because there were fewer network hops, we saw lower latency from getting our data from CockroachDB into our data warehouse.